All right, so you probably know about some specific angles here. So, for example, 45 degrees.
Yep, that would be pi over 4.
This would be pi over 4. And so, what's cosine of 45 degrees?
Root 2 over 2.
And if you look in like a calculus textbook or something, you'll instead see that cosine, they would write it as cosine of pi over 4 equals root 2 over 2. So 45 degrees corresponds to pi over 4. And again, why does 45 degrees correspond to pi over 4?
Because, I guess, it's 45 would be halfway between 0 and 90, and or it would just be an eighth of the way around the circle.
Okay,
which is
good.
pi over 4.
All right, so now I'll give you a challenge. What does 30 degrees correspond to? Did I tell you this was called radians?
I think I knew it was called radians.
Oh, you did? Have you heard of this before?
Yeah.
A little bit. Oh, okay, good. Actually, I didn't know that, but okay. Yeah, so this is called radians. So what does 30 degrees correspond to?
Well, that's a 12th of the circle, so it would be pi over 6 radians.
Okay, good. And then here's another one. How about 72 degrees?
72. Oh, that's a fifth of the way. So, I guess just 2 pi over 5.
Okay, very good. That's nice. Did you talk about radians in school, or have you just heard it before?
I've heard it before.
You didn't talk about it in school?
No.
Oh, okay. All right. So you just heard the word. Yeah, and so this is actually something really interesting that you'll see every now and then. But you might wonder why. This is a natural way of talking about these functions, actually.
Yeah. It seems sort of similar to degrees. Like, I mean, every value for radians has a corresponding degree value.
Yeah, that's right. That's right. It does. Well, I'll show you just sort of a simple answer to why. Not in a way that I could explain to you fully right now, but it's actually kind of neat.
All right.
All right.